Now that we've built out our matrix, we're actually going to use the calculator to help us to check our solution. So we actually haven't done anything with technology yet. This is where the technology comes into play. So where the calculator is going to help us out in the checking. Let's walk through the steps for entering and solving a matrix in the calculator. So again, this was the system that you guys had on the bottom of the last page. Remember, to put it in standard form, we had to take the negative x and move it in front of the y like that. So that made that a negative x plus 2y equals 5. And then this guy, we had to take the 4y and actually subtract it to the whole other side of the equation, making it 3x minus 4y equals a negative 1. So the matrix we were able to develop from that was negative 1, 2, 5, and then 3, negative 4, negative 1. Okay, so we're ready to go ahead and put that into the calculator now. So I'm going to come over here. I've given you some screenshots of the calculator, but we're going to put the buttons that you guys are actually going to press to get to these places up above. So when I write a button, I'm going to put it in a square or in a box so that you guys can look back and know that was the button we pushed. So to get to this screen right here, we are going to go second, and then we push the x to the negative 1 button. Written in blue above x to the negative 1 is actually matrix, which is what we're trying to get to. So over here on the calculator, we're going to go second, and then x to the negative 1 is right here. And that gets me to this menu right here. This and your screen may look slightly different from your screen. This is just because there have been a lot of matrices already added to this screenshot. Over here, I've already done one matrix. I'm going to just keep redoing that matrix, so I don't need all of these other guys. All right, so once we get here, we're going to use our right arrow, and we're actually going to push that arrow twice, so times 2, and that gets us to this menu right here, the edit menu. So notice edit right up here at the top. We're going to use our arrow to get to the edit menu. We need to edit this matrix, so we're going to press enter now. So after you're on the edit menu, press enter. All right, what we need to enter once we get to the screen, notice that's what I have here. The dimensions are going to be slightly different. So we need to do our dimensions. So enter dimensions, then elements. So remember, we said over here our dimensions were rows. We have 2 rows and 3 columns. So over here our dimensions are 2, enter, 3, enter. And as we do that, it gives me 2 rows and 3 columns in our matrix. Then we're going to enter our elements. Notice I already have them entered, but we can just type negative 1, press enter, 2, enter, 5, enter, 3, enter, negative 4, enter, and negative 1, enter. Okay, so that's all we're doing right here on this screen is actually entering in the dimensions and the elements. Step number 3, I do not have a screenshot because you're going back to the home screen. So we need to second and mode, which written above mode in blue, it says quit. That gets us back to the home screen. So second and mode takes us here, quit. We've got to get out of the matrix before we can actually do any kind of calculations with the matrix. So step number 4, we're going back to the matrix menu. So we got there by doing second and x to the negative first. And this time we're going to arrow over just once to get to the math menu. Once we get to the math menu, we need to do option B. Okay, so on the calculator, what that's going to look like, second, matrix, arrow over to the math menu. So we're going to do the arrow one time, and then we need to get to option B. You can arrow up is a little shorter, or you can use your down arrow, but we just need to get to option B and press enter there. What that does is that puts RREF on my home screen. RREF means reduced row echelon form. All right, I'm not going to test you on that, but it's kind of nice to know, hey, there is a meaning behind RREF, reduced row echelon form. So notice here we have reduced row echelon form with a blank. Notice over here on your notes you have reduced row echelon form with A. So we need to tell it we're using matrix A, which is the one we created here, down here in our reduced row echelon form. So in order to do that, we're going to go back to the matrix menu one more time. So second x to the negative first. So second x to the negative first back here. And this time you're just going to select that matrix right here. You could select any of the ones that you enter data in, but typically for you guys, we're only going to use one matrix. So you're just going to select matrix A. So select A. You can do that by pressing enter. And notice now it put our ref of A on your home screen. That's this. And when we press enter one more time, it's going to give me this is your solution matrix. So we're going to label that guy here. This guy right here is your solution matrix. Sorry, guys. Matrix. There we go. Okay, so this was a different system, obviously. So this was a different solution matrix. What I need you guys to do is to copy down this solution matrix onto your notes over here. So the solution matrix we got is 1, 0, 9, 0, 1, 7. And then I'll show you guys how to read that. Okay, again, you're copying solution matrix from here onto here. So remember when we put this matrix in, when we set it up, it was AX, BY equals C, right? This is our standard form. So this is your X column. This is your Y column, and this is your equals column. So you can actually put a line down here, or sometimes you'll see a dashed line there, and that just kind of stands for your equal sign. So the way that I want you guys to read this is by row and column. So X, this is your X column, 1X is equal to 9. Then I want you to take a look at your Y column. Y is equal to 7. So if you read all the way across the row, what this means is 1x and no y's equal 9. So x equals 9. If you read across this row, 0 x's and 1 y equals 7. So y equals 7. So interpret the results. Remember, a system of equations is an intersection of two lines, which is a coordinate point. So what we're looking at is the x value of 9 and the y value of 7. So that means these two lines would intersect at the coordinate point 9, 7. Okay. What I need for you guys to do now, I've given you two systems down here. To get you a little bit of practice in solving those systems, I need you guys to just solve the system by substitution or elimination like we've been doing. And then once you do that, come back here and use the matrix to check that system. So I'm going to give you guys these two. Pause the video, solve the systems, check them using the matrix. You can also do this on the previous worksheets that we have done. If you don't know what the correct answer is, you can check it using a matrix. This is also a good method for you guys to check yourselves on the upcoming test. Okay, if you're back, hopefully you were at least able to get through the first one. I did notice the second one was a little meaner than some of the 3 variable ones that we've done before, so I was going to talk you guys through that one. So over here, what I did for this 2 variable system was just substitute in place of the y. So y equaled 3x plus 7, so I put that in place of the y here. Came down through here, and if you'll notice when we simplified here, negative 6x and a positive 6x canceled. What was left was negative 14 is equal to negative 14. So all of my variables canceled. What was left is a true statement. Therefore, this will be infinite solutions. If all of your variables cancel and what is left is false, then you have no solutions. Okay, I want to show you guys what that looks like as far as the matrix is concerned. So remember, when you do a matrix, you do have to set it up in standard form. So I rearranged my equations here to put them in standard form. This is what my augmented matrix would then look like. I went through the calculator steps from up above and plugged them in. And what I want you guys to notice is the solution matrix looks a little different. When we have a 0, 0, 0 all the way across the board like that, that is what is indicating that this is infinite solutions. Okay, so here's the idea. If you come up with infinite solutions and you want to use the matrix as a check, you plug everything in, and if you get 0, 0, 0 across the bottom row, Bottom row 0, 0, 0 tells you you have infinite solutions. All right, hopping back up here to the 3 variable equations. These guys are all mixed up all over the place. I notice I have a 2 variable equation here, so I'm thinking that's probably my best place to start because I have 3 variables in this equation and 3 variables in this equation. So hang tight with me on this one. This one is going to be interesting, but I think it'll be good practice for you guys. So I'm going to solve this guy for y. So we're going to do plus 5z plus 5z. So y equals 5z minus 3. And I'm just going to hold on to that for just a minute. So I'm going to highlight that and just kind of hold on to it. Then I'm going to take my other 2 equations, these guys right here, and I'm going to put them in the same order. Preferably standard form is going to be your best bet. So take these 2 guys and come down here, and we're going to put them in order. X, Y, Z equals number. So notice here my X is on the wrong side of the equal sign. So I'm going to add X to both sides. And then I'm going to put him in front. And then my y needs to come next, but he is not changing sides, so he does not change signs. So when I rewrite this, it is going to be x and then minus y and then plus 3z is equal to 3. That is this guy right here in standard form. So I added my x to the left side of the equation and then flip-flopped my z's and y. I'm going to do the same thing down here with this guy. I already have my x in front. That's good. My z's and my y's are again out of order, so I'm going to take my y's and move them in front of my z's, so plus 2y. And then minus 6z is equal to, now here's the other problem. This constant right here does not need to be on the left side of the equation, so we're going to add 6, to get that constant over to the other side as a positive 6. Okay, 3 variables. We need something to eliminate here. And if you'll notice, when I add these guys up, it adds up to -1. When I add these guys up, it adds up to a +1. And when I add these guys up, they add up to a -3. So nothing eliminates yet. So I think maybe what if we try to eliminate the x's? If I try to eliminate the x's, I need this coefficient to be a +2. All right, so y'all hang tight and watch this for me. So if we take this equation right here and we multiply it by 2, that's going to make this coefficient a +2, which is the opposite of the -2. So I'm going to take that 2 and distribute it in, and then I'm going to rewrite this equation down here as being multiplied by 2. So 2 times x is 2x. 2 times -y is -2y. 2 times 3z is +6z. And then 2 times 3 is 6. Uh-oh. All right, let's draw our line and add these up. Hopefully, y'all, as y'all were writing, maybe you saw a little bit of what I was saying uh-oh about. So if we add up here, these guys are going to eliminate. These guys are going to eliminate. These guys are also going to eliminate, and I'm left with 0 equals, wait a second, 12. True or false? That's false. So this guy has no solution. All right, so false statement, no solution. Building the matrix out on this. The difference, I need you guys to notice a couple of things here. We have 3 equations. If I was to put all of these in standard form, it's going to be x, y, z equals number. So this guy in standard form, we have already written that one down here. So I'm going to write all 3 of them in standard form. X minus y plus 3z equals 3. We have -2x plus 2y minus 6z equals 6. And then for this guy right here, we had not put it in standard form yet. He's already in alphabetic order. We have y and then z and then equals a number. What would the the x value be if there's not one there? we understand that to be a 0x. So we kind of use that like a placeholder. So plus y minus 5z equals negative 3. All right, so these guys would be our matrix in standard form. So to write that matrix, we would have 1, negative 1, 3, 3, negative 2, 2, negative 6, 6, 0, 1, negative 5, negative 3. What are the dimensions for this matrix? So notice, bigger system, bigger matrix, bigger dimensions. Our dimensions here would be 3 by 4. So when you go to plug that into the calculator up here on this step, your dimensions are going to be different. You're going to have a 3 by 4 matrix now. So plug that into the calculator, and the solution matrix that you get here looks something like this. We have 1, 0, negative 2, 0, 0, 1, negative 5, 0, and then 0, 0, 0, 1. Okay. A solution matrix for a reduced row echelon form should always have 1s diagonally down the screen. So I know we only did one of them up here, but notice here, solution matrix diagonal 1s. Over here, solution matrix diagonal 1s. If you don't have all the diagonal 1s, then it's going to either be an infinite solution or a no solution. So notice here 1, 1, and then we have 0 as our diagonal. That's kind of a heads up or a warning that, oh, this is going to be a no solution or an infinite solution. So then we take a look across here. Remember how I told you guys this is kind of like your equals is down through here? Right, over here, this would be your equals down through here. Does 0 equal 0? 0 equals 0. That is a true statement, which is why you get your infinite solutions. Down here, does 0 equal 1? No. That is what tells me this is a false statement, which is what tells me we have the no solutions. So these are what your solution matrices are going to look like if you have a no solution or if you have an infinite solution. It doesn't happen very often, but I did kind of want to throw that in just to remind you guys about that situation with our 2 and 3 variable systems, and then also what that's going to look like as far as a solution matrix is concerned. Okay, use the matrices, practice for a little bit for me. Try to check your worksheets that we've done that have these systems on them. Try to go through and check them using matrices so that you know that you're doing your substitution and elimination correctly. And then obviously this would be a good method for you guys to also use to check your answers when you guys get onto the test.